Okay, so statistics. We're going to start out, there's a lot of vocabulary involved. If you get deep into statistics, it's almost like learning a second language because there's a lot of unique words that are used and then a lot of other words that are common words that are used in a unique way. So we're going to start out, statistics is basically about gathering information. And the first concept you need to understand is the concept of a population. A population is a group of items that share a common characteristic. And for statistical purposes, it is the group that we want to learn about. Now that might be more difficult to define than what you might think. You have to be very careful about how you define the population. Now we just went through a presidential election, so this example is a little bit worn, but let's say you want to learn about, there's a new city ordinance that's on the ballot to be voted on for the next election. And you're trying to learn, is it going to pass or not? What do you think it's going to pass? What we're trying to learn about there is not the ordinance itself, because the ordinance itself does not determine whether it passes. What we want to learn about there is the behavior of the voters. So our population, it would be easy to define the population as all the voters within that district, but that's not what our population is, because not all the voters are going to vote. What our population would be there is all of the people who will vote in the next. In that next election. Notice I didn't say registered voters or anything like that, because every election there are people who vote that probably aren't supposed to, and there are a lot of people who are able to vote that don't. So that's a very carefully defined population. Now it's possible in some cases to contact every person in that population. Now it doesn't have to be people, by the way. Our population could be items. It might be products if you're looking at quality control and manufacturing. It could be a lot of other things could be our population. It's just when we're talking about business, it's usually easiest to talk about people. But we could contact every person in that population. We could gather information from every item in that population. But in most cases, we don't for several reasons. What we do is we choose a sample. A sample is a smaller group chosen from the population. Why do we choose a sample? Well, that's one of our goals in choosing a sample, is to make it an accurate representation. But the reasons why we choose a sample, the number one reason for doing most anything in this world these days, money. Yeah. Cost. The cost of gathering information from every member of that population could be prohibitive. Now, I know phone bills aren't what they used to be. It used to be you got charged per call, and that's not necessarily true anymore. But you still have the labor of having people call them, or the cost of sending out paper surveys and getting them returned to you. The second one is time. Depending on how many voters are in that district, it could take a long time to contact every one of them. Now, I usually use the example of a presidential election. Well, that's nearly impossible. There are about 120 million registered voters in the United States. Contacting 120 million people and getting information from them is very difficult to do. It's costly, it's very time consuming. The third reason is identifying the population. How many people here have missed voting in an election? I have. I can admit to it. Most people have. There are some people that don't know right up until the morning of the election whether they're going to go vote or not. So to identify who's actually going to vote and who's not, it can be almost impossible to identify everybody that's in that population. And in other populations, the same type of thing. There might be overlaps between populations or blurry lines, fuzzy lines in between different groups. The fourth reason, I'm going to have to discuss this one a little bit, is changes over time. I'm sure you guys recall from the presidential election just a couple of months ago, it seems like every day there's a new story out, and half the time it's a new scandal. Oh, this person said this to upset a whole bunch of people, or this person's accused of this new scandal, or whatever. You have a small time window. Ideally, you'd gather that information instantaneously. You get the information from everybody that you decided to sample, or every item in your sample, all at one instant. It's a snapshot. We're looking for a snapshot of that population, that sample. If you take too long, if you're trying to get information from too large of a sample, it's going to take time to get that information. If you take too long to gather that information, people that you've already gathered information from may have changed their mind, or the circumstances under which you gather that information may have changed. If I start today, let's go back to the election, and we're not going to choose sides, but the Trump versus Hillary election here. And let's say that I start today, and today the reality is a small majority of the people are in favor of voting for Trump. So I start surveying people today, and I'm getting a majority of them are saying they're going to vote for Trump. Well, then tonight on the evening news, the news comes out with something really stupid that he said today. And tomorrow I'm surveying people. Well, I'm surveying them under different circumstances. Now I'm getting a majority are saying they're going to vote for Hillary because they're mad about what was said last night. Well, the people that I surveyed yesterday, a portion of them may have changed their mind based on that. But I'm not going to go back and get that information from them. So I'm taking information under two different conditions. You have to get that information in a small enough period of time that things haven't changed. Does that make sense?
Yeah.
I'm just going to say logistics. Basically impossible. Even the people that you, or the items that you choose to be in the sample, sometimes it's not possible to gather information from them. Some people won't return a mailed survey. Some people won't talk to you on the phone. Some people, you corner them in the mall, they're not going to talk to you. There are certain elements in each population that just aren't going to give up that information. So you're not going to be able to get that information. Every 10 years, the United States government tries to do a census. A census is an attempt to gather information from every element in the population. So for the United States, that's every person that lives in the United States they're trying to gather information from. They're never successful because there are always some people that are just going to flat out refuse. Now, a lot of people don't realize it, but in the United States, it actually is a federal crime not to respond to the census. They don't prosecute people over it, but they go through great lengths. They'll spend 2 or 3 years. They actually go to the homes, last known addresses of people who haven't responded. They go through great lengths to try to gather that data, but they have never successfully gathered information from every man, woman, and child in the United States. It has never happened. The last one hopefully doesn't apply to people. And I'm just going to, the best way I can describe it is destructive testing. This applies more on the manufacturing or industrial side of things. The example I use here is, okay, let's say you're working quality control for a manufacturer, and you have a part that needs to be able to withstand a certain amount of force. So it needs to have a minimum strength. How are you going to test that? Well, you're going to take a part off of the assembly line and you're going to put it in some sort of a tester. Let's say you got a machine that's going to stretch it. It's going to pull on it. So you put that part in there and you let the machine stretch it until it breaks to see how strong it is. Because a lot of people say, well, why don't you just apply the amount of force that it needs to be able to hold? Well, that doesn't work because sometimes, you get different angles or extreme conditions, you get a little bit more. It has to be able to hold a certain percentage more force than what it's designed to in order to be considered adequate. So generally, they just stretch it until it breaks, and they read what force it was able to withstand before it broke. So now this part is broken. Obviously, you can't sell it. So if you tested every part that came off the assembly line, there wouldn't be anything left to sell. So that's another reason for taking a random sample. If your testing process is destructive, you can't test everything. So we mentioned the word census. A census is an attempt to gather information from a population. Unless you have a very, very small population, a census is seldom successful. A parameter is a piece of information that describes the population. Now, this is one that is often confused, so let me expand on this a little bit. I am not talking about saying, oh, the population consists of men and women between the ages of 18 and 67, or whatever that is. That's describing the population itself. What we want to describe is a variable of interest. In other words, what we want to learn, or what we are trying to learn. So if we are trying to learn about who's going to win that next election, how voters are going to vote in that next election, a parameter would be a statement saying, based on our information, we believe about 60% of the voters are going to vote in favor of this new ordinance. That's a parameter. It's a statement about the population based on what it is we are studying. So it's not saying, we surveyed, the population consists of people between the age of 18 and whatever. It's not describing the population that way. It's describing it about what we are studying. Well, then next we have a survey. A survey is the equivalent of a census. It is an attempt to gather information from a sample or about a sample. A statistic nice to define the word that we're learning about, right? A statistic is then that piece of information describing the sample then. And again, it has to be related to that variable of interest. So we might state "63% of people surveyed indicate they will vote in favor of," we're just going to say ordinance A, just going to say A. Or we might say that we conclude that about 60% of voters will vote in favor of ordinance A, or item A. Which one of these is a parameter? The second one, because we are stating we conclude that about 60% of voters, of all voters, that's making a statement about the population, and it's related to our variable of interest, of the results of how they're going to vote on this item. Now, it may or may not be true, depending on how good our sample was, but it is a statement about the population. So the other one is a statistic, because it is making a statement about that survey. And it says right in there, 63% of people surveyed indicate they're going to vote for it. Generally, a statistic is more exact because we're just making that exact statement about our sample. The parameter is usually a little bit more generalized, about 60% or at least 60%, sometimes it'd be stated, because we're taking the information from that survey and we're now generalizing it about, applying it to the whole sample. There are a lot of potential pitfalls in using samples to gather information.